Okay, here's our math practice. So our first experiment is if we're dissolving Kool-Aid in water, what's going to happen? So it asks us to write a hypothesis. So if we add Kool-Aid to water, the mass of the system will not change. It is one possible hypothesis. So our procedure, we get a balance. We take a small cup and a glass, and we toss them on a scale, get a small amount of Kool-Aid, put that in the cup, got a half full of water, mass of everything together. Now dissolve the Kool-Aid and measure the mass of everything together, which is why I said back up here that I didn't think that the mass would change. That's what we mean by system. So dad table, we'd have the mass of a cup with water, and it looks like a cup with Kool-Aid. And that'll be in grams. And then we'd have the mass of an empty cup and the mass and a cup with dissolved Kool-Aid. Again, that's in grams. So what did the particle picture of the Kool-Aid and water look before we mixed? Well, initially we had a solid Kool-Aid, so that could be this one, maybe even this one, right? And then we had, so that eliminates this one, and we had a liquid water, which this is the only one that looks like a liquid to me, so I would pick B. And then at the end, what happened? Well, the reason it dissolves is because we can't see those particles, so this is the only choice. This one would imply that it stayed a solid inside of the water, so that's not it. None of the other ones have the water as a liquid, really, so this is the only one that, A is the only one that sort of works. Okay, Jimmy found the mass of the cup and the glass and their contents before mixing to be 27.53 grams, and then it was 27.49 grams. So what's the difference in mass? 0.04 grams, right? And then you guys would show work, obviously. Is there a significant change in mass? All right, so this is what we talked about before, right? So this is significant here means, less than 3%. So let's see if there's less than 3% change. So for every, the percent in error is 0.04 grams. And what we should have gotten of error out of possible 27.53 grams, which is what we should have gotten. And then down here we've got 100 grams. And if we think about this, 25 times 4 is 100, so that means that this number is a little bit less than 4. And how many grams of error do we have out of 100? So this is going to be times something a little bit less than 4. Well, even if this was 4, this would be 0.16. So it's going to be a number less than 0.16. That is definitely less than 3%. So we're going to say, no, that's not significant at all. Maybe the scale was a little off. Maybe somebody was walking by, got a little bit of wind. Why do we put the empty cup on the balance? Because we want to make sure that we mass the whole system. And because that cup was part of the original system, we want to make sure that it's part of the ending system. Okay, so Ms. Piaczynski likes her apples cut up into little pieces. She took the largest apple she could find and found its mass to be 20 grams. She then cut it up in smaller pieces and measured the mass of all the pieces. So what do you think should happen? It probably should stay the same. And before and after, so this is n equals 5, so we're just going to say, okay, initially, I screwed that up. Initially, we had 5 particles, and they were all together. And after, maybe we have 5 apple particles, and they're all separate. So the change is none. Mr. Rubicek likes to cut his own trail mix. He mixed 15 grams of peanuts and 25 grams of M&Ms. What is the total mass of his trail mix? Okay, well, the total mass is 40 grams, 40.0, because we're in the 10th place here and the 10th place here, which means you round to the 10th place there. So before, we got, all right, let's let circles be peanuts and triangles be trail mix. So initially, we've got 5 of each. So we got peanuts. They're kind of close together, but not on top of each other. And some trail mix. And afterwards, the peanuts and the trail mix are kind of mixed up as we go. That's not a very big mix-up, but the N equals 10. Okay, Mr. Swistak has been really sick lately. Well, that's not true, but we'll talk about that. Let's see here. He decided to make some tea, hot tea, and hopes of feeling better. Before he got to drink it, though, he sneezed all over the counter. That's disgusting. And some of his sneeze particles got inside his cup of tea. Draw before and after particles. Okay, so here we've got some hot water, right? So we've got water. All right. We got maybe 5 particles of water. And then we got triangle. We'll make that snot. And so we've got 5 particles of snot. And that snot is kind of like all together, right? So I don't know. Oh, maybe not. Maybe it's just kind of like all over the place. That's kind of how snot works, right? It's kind of like maybe a couple particles are together. And then afterwards, now we got 10 total particles. So now in the water is a bunch of snot, right? Kind of like evenly dispersed, but maybe some of it's a little chunky, right, in there. All right. Mrs. Amadei likes to drink her coffee with a lot of sugar. She bought a medium cup from Dunkin' Donuts and decided to see if the mass of the sugar will affect the mass of her coffee. She measured the mass of her cup to be 24 grams. She then dissolved 8 grams of sugar into her coffee. Total mass is 32 grams. Now, why isn't it 32.0? These are both to the ones place. All right, so, and then the other one, we've got our sugar, which is triangles, right? And that's initially all together. We've got 2 packets of it, right? So we'll put 2 solid particles. And then afterwards, volume goes up a little bit. And then we got a bunch of triangles mixed up, and it's mixed kind of evenly in here. 8. Okay, Mr. Panzolius likes to drink his soda frozen, measure the mass of the bottle of Sprite, put it in the freezer for a few hours, draw a before and after picture of the bottle of Sprite. So initially, we've got particles of Sprite, so water. Let's just assume Sprite is its own thing. And then afterwards, the particles get a little bit closer together, which isn't true for water, but that's okay. Still got the same number of particles, and that's the important part. Mr. Ward likes to drink his soda flat. He loosened the cap on a bottle of Pepsi and left it in his office for a few hours before he draw before and after. All right, so now with this one, we know that he opened it. So initially, we've got a closed bottle, and in that bottle is some bubbles and some water. All right. So let's put some bubbles and then some water in there. And then afterwards, maybe we've got only 2 bubbles. And then there's a bubble outside. So I would say n equals 5 and n equals 3 and n equals 5 and n equals 2. So it's got a little flat. Okay, I hope that helps. I know it's a little bit long, but you should be okay for the quiz if you can understand that. Okay, have a great one, guys. I'll see you Tuesday.